Okay, this is a video to help you understand how to find determinants of 3 by 3 matrices using row expansion. Remember, there are three parts to it. The first part is using the cofactor, which is simply going to be -1 times the row plus the column that we're dealing with, and you'll see that in just a second. The missing element, which I don't know what you want to call that. We'll call it S for Sean. And then the minor, which is the minor, and then that's the row and the column of the minor that you're finding. So really, I mean, if we're just making something up here, we're not really making it up, but just all the things that stand for something. It's -1 times the row plus the column times the missing element, which is S, times the minor of the row and the column that we'll be talking about. So check this out. If we wanted to find the determinant of this 3 by 3 matrix, what we would do is we would first off we would have to do this in 3 parts. The first part is going to be the cofactor of -1, and it's going to be the cofactor of, we're going to expand on this row right here. So the first thing we want to do is find the cofactor of, and we want to work with this column missing. So the missing element is going to be 3 right there. And then my minor is going to be 6, 2, -2, 3. Okay? So it's -1. We're dealing with row 1, column 1. So there's my cofactor times the missing element 3 times the determinant of that minor that is left over with this column being gone. So 6, 2, -2, 3. And then we're going to do that 2 more times, except for the other 2 times we're going to be missing the second column, and then we'll be missing the third column. So if you can kind of envision, -1, we're expanding the first row, and now we've shifted the missing column over to the second column. That makes the missing element right there 4. And then we're talking about the minor. Now that we've got that, now our minor is the determinant of 4, 2, 8, and 3. So let's see here. 4, 2, 8, and 3. And now we're going to shift over to the third column. So that would be the cofactor -1, 1 plus, this is the third column, first row, third column. The missing element is going to be -1. So times -1. And now that this is missing, our minor is 4, 6, 8, and -2. 4, 6, 8, and -2. And as you can probably see, this is going to be really easy to make some arithmetic mistakes. So let's take this one piece at a time. And the determinant is simply the result of all 3 of these added together. So again, this -1, what we're trying to do is we're trying to figure out what the value of this missing element is going to be when we add all 3 of our pieces together. So 1 plus 1 is 2, which makes the negative go away. So -1 quantity squared is +1 times 3 is 3. So that was this part right here. That was all this that I just did right there. I just did all that. Right? And then the determinant is 18 minus -4, which is, what is that? 18 minus -4, 22. So this is 66. Coming down to this one, the negative is going to stay because it's going to be -1 to an odd power, so that's going to be -4. That was this part right here. Times the determinant is 12 minus 16, which is another -4. So 66 plus, 66, and then now we're going to add 16. And then we've got one more, which is going to be, this is going to give me an even power right here, so that -1 is going to be +1. +1 times -1 is -1 times -8 is this diagonal for this determinant right here. We're finding the minor. There's another video for that if you forgot how to do it. And then 8 and 6 is 48. So negative 8 minus 48, oh, what is that? Negative 56. So negative 1 times negative 56 is positive 56. And we want to add all of those together to get the determinant of A. So the determinant of this matrix, let's just make this matrix be A. And actually, if it's going to be a matrix, we need to do this then, remember? So the determinant of matrix A is all of these added together. So 66 plus 16 plus 56. So the determinant of A would equal 138. And that is an example of how we do a 3x3 matrix using row expansion.